Welcome to session 14 of Coffee with Coral. In this webinar, we'll discuss WTI's redesigned Viper H.265 PTZ camera and the Hydra 265 transcoder. Let's join the session in progress.
Perfect. Well, first of all, Ryan, thank you for inviting us to do this. I think it's the second time that we've participated in Coffee and Coral. Clearback last fall, I think, was the first time. So again, we appreciate the opportunity to be with you and kind of share a little bit about the WTI products.
We appreciate you joining us.
So WTI, for those of you that are not familiar, we are a company that's based out of Ventura, California. We've been around since the mid-1980s, and we started off making wireless radios, thus the name Wireless Technologies Incorporated. Since that point, however, we have transitioned away from the wireless radio industry, and we have become a manufacturer of cameras. And so the ones that we're going to be talking about today, the Viper series cameras, is just one of the different cameras that we manufacture. We have hundreds of thousands of cameras that are actually been deployed across the country. A lot of those are in our OEM side of the business, and they are branded under different names. If you guys are familiar with Econolite, that's probably the #1 company that we do OEM work for. So their detection cameras are manufactured by us. So even though you may not realize that you have seen a WTI camera, you probably have. We are an ISO 9001 certified company. For those of you that are not familiar with that, that's a manufacturing standard. So basically just saying that we go through a stringent process in our manufacturing in order to be able to guarantee that we provide a quality product every time that we send one out. Next, Lester.
Okay.
So the Viper series cameras, we're going to start off with a few little videos, just kind of showing some of the capabilities. This first little video is just showing how the distance of it. This is from Ventura. We're looking out, and there's an oil derrick that's off the coast there about 10 miles. And you can kind of see that you can kind of reach out, and you can kind of see that it is an oil derrick even 10 miles away. When it zooms in there at the very end, you'll notice it gets all pixelated. That is when the camera goes into the digital zoom. So the camera has 30 times optical and 12 times digital zoom. So it kind of, when it gets in here, I'll tell you exactly where it kind of switches over to the digital. Right there. So just to kind of show you what the capabilities are of that. Go to the next recording. This one right here is kind of more of what it would be like in a traffic situation. So this is just about a mile. So we're going to zoom in on a parking lot. And you can kind of see at a mile, you can pretty much see whatever you would like to see. So from a mile out, you really couldn't even tell that there was a parking lot there. And you can zoom in and you can actually, see the guy doing his work and reading on the side of the van and whatnot. And then the next two videos are videos that just are software-driven features. So if you'll notice on the back side of those trees there, it's really dark. And then when the wide dynamic range feature is clicked on right here, you'll see that the backside of the tree, all of a sudden you can tell that it's a tree and there's the shadowing is gone. And so what that does is that basically extrapolates out and says, okay, this is a tree and this is what it's supposed to look like. So very, very good to be used in situations where you've got glare or low light, situations where you're seeing shadowing behind things. And so that's something that you can turn on and off within the camera anytime you would like. The next one we're going to show you is for the defog feature. And this is something, again, software driven. This is like the foothills of Ventura, and there's like some mist off the ocean and stuff like that. When that clicks on right there, you can see all of a sudden the bushes and the ridge lines become kind of accentuated so that you can see them a little bit better. And that's how the defog feature works. In traffic, it would be used like underneath bridges or in low-lying areas where you have fog. And it just allows you to turn on a feature that you can basically see things a little bit, the definition of things a little bit better. The next slide here is talking about the H.265 Viper. So we have two different cameras within the Viper series, and there's an H.264 camera, which has been available for the last 4 or 5 years. And then just this start of this year, we launched the H.265 Viper camera. The H.265 Viper camera uses 50% less bandwidth than the H.264 camera. Still has 8 independent streams, 30 frames per second, power consumption 62 watts, and it is a PoE powered camera only, whereas the H.264 camera is available in PoE or AC power. This next slide right here talks about it's all aluminum housing, the only camera on the market right now that has 360-degree rotation on the pan and tilt axis. We have some self-cleaning thermostatically controlled glass that we'll go into a slide a little bit later. That's kind of, I think, one of the big advantages of this camera. It's a IP68 rated camera, which if you're not familiar with that, basically it just means that you can throw that camera in a bucket of water 3 feet deep and leave it there for 20 minutes and it's not going to get damaged. And so for wet areas, anywhere you have a situation where you're trying to keep sand, dirt, water, whatever, not out of the camera and kind of lengthen its life, it's a very, very important feature. Minus 40 degrees up to 165 degrees. There's 2 levels of transient protection using gas discharge tubes. This is something that is kind of unique to our camera as well. So when you have situations where you have power outages or lightning strikes or things like that, the cameras are very susceptible to having damage in that way. The boards that we manufacture right in Ventura, we put on these gas discharge tubes that basically act as kind of a surge suppression to help keep the boards from getting damaged in those types of situations. And then we also use a low light camera block from Sony that gives us really superior low light technology. A new feature that we just kind of have done some testing on is the mean time before failure. So the very last bullet point on there, 11.83 years. And this is something that we're really, really proud of, because when we're kind of looking in the marketplace, one of the things that we're noticing is with domes and with some different style cameras, like if they get 3 to 5 years of use out of that camera, then they're tickled pink, and it's kind of become a disposable marketplace. As pricing has come down, the quality of the cameras has gone down as well. Whereas our camera, in the real life world of situation, if it's going to last almost 12 years out in the marketplace,
did we lose Doug? Hello?
Situation where maintenance costs, you're not going to have.
Doug, we're losing your audio.
Hear me?
Doug, we're losing audio.
Can you not hear me at all?
Yeah, that's better.
Is that better?
Yeah, we lost you right after you started talking about the mean time to board failure.
Oh, well, that's not good.
And I lost you again.
It's going to save a lot of money on maintenance costs. One of the things that's happening in the marketplace is with dome cameras and everything else is the prices get cheaper and cheaper. So does the quality of that product. And so if, different places, if they're getting 3 to 5 years of use on a camera, they're kind of considering that kind of par for the course, and they're just becoming a disposable entity. Whereas these cameras are designed to last in a traffic environment for upwards of 12 years. So very, very important feature. Next slide there, Lester. You just show the different things within the camera: 64 preset, 8-quarter, 32 presets before, 2 lines of camera titling, built-in azimuth and compass, logo overlay. Again, we've talked about the environmental minus 40 to 165 degrees. All the cameras are wind tunnel tested to 150 miles per hour. So very, very durable in that situation. But we also offer an ENG brake option, which this is something that's being currently utilized in a lot of locations on their service vehicles. So WashDOT uses them on some of their service vehicles. If you have areas where you've got very high winds like gusts and things like that, it just guarantees that the camera is not going to move. It literally puts a lock on the motors so that they are not going to. This next one talks about, the H.264 being available in PoE as well as AC, and the H.265 only in PoE. And then the very last thing there, the low light sensitivity. We've got some pictures we'll show you here in a second that are very telling on that as well. Next slide there. Lens 30 times optical, 12 times digital, like we talked about. The resolution is 1080p, clear down to standard depth. So you can modify the resolution on these cameras to whatever you'd like, depending upon your viewing capabilities, or if you have a bandwidth issue. Which, when we talk about bandwidth issues, a lot of traffic management centers, they have these nice high definition cameras, and they're streaming at 720p because, quote unquote, even though they do not have a bandwidth problem, they don't have enough bandwidth in their TMC to bring in all the video feeds that they have and stream those at 1080p. And that's where the H.265 camera really comes in handy, is because it's using less bandwidth than the H.264 camera, and thus allowing you to pop up those resolutions so you can truly utilize a high definition camera instead of basically having standard depth feeds. Electronic image stabilization, wide dynamic range, defog, we talked about those a little bit. Another thing, the camera is very, very light at 14.5 pounds. It's probably one of the lighter cameras of its style. In fact, if not the lightest camera, and very comparable to most domes. Next slide. So the hydrophilic self-cleaning glass. This right here is a unique feature that we're the only manufacturer that's using it on our cameras as well. And what we do is we actually take the glass and we will fuse titanium dioxide molecules to the front side of that. And what that does is it creates a flatter surface. And so when water hits that, instead of beating up or just kind of staying there, like hydrophobic does, hydrophilic will flatten that out, and it pushes off all the debris and matter. One of the best examples that we've had with this is, and this is when we first started using this technology, it's been way back 10 plus years ago. In Missouri for KC Scout, they had a situation where a lot of the birds, land on the cameras, and then they would have a little, poop on there and whatnot. And so pretty soon, they'd have to go up and clean the cameras that they were using. So they installed some of these cameras. They got a bird that pooped on one of them, and they had scheduled to go up and clean on this. Well, that was about 2 or 3 weeks later. It was all getting hard and crusty, and the maintenance people were like, "Yeah, there's no way that's going to come off. We're going to have to go up there and scrape it off." Well, it rained a day or two before they were supposed to go out there. They flipped the camera tube up into the rain, and the next morning it was completely clear, as if there was nothing on it. And that was the first time they'd ever had a camera do that. And so that's exactly how it was designed to happen. And we tell a lot of people to have the cameras on a preset to where when it rains, they can just point it up and they can get a little bit of moisture on there, and then it will come off. And the back side of it, we do a similar process with indium tin oxide, and it is an electric conductor, so it conducts electricity, keeping that glass warm. And we'll show you some pictures here of how that kind of is an advantage over some of the other manufacturers you can beat taking that off. And by the way, if anybody during this presentation, if you have any questions, please just jump right in and interrupt me. I know a lot of you have already seen a lot of this stuff, so it may not be new to you, but there may be some finer details that you'd like to ask a question on. This next video here is of rain, just kind of showing how the camera performs in a rainstorm. And so this was a rainstorm in Ventura, and it doesn't look like it right now, but the rain was pointed directly into the camera lens. And so, you know, it's beating up on there and whatnot, but it's still, you know, looking pretty good as far as an image goes. As the video progresses, it'll pan and you'll see that the rain was beating directly on it. And then one of the features of the camera is the sun shield that goes all the way around. And this, as you know, kind of protects it a little bit from rain if it's not beating you directly on there. And you can kind of see that it will allow that image to get better. As the video progresses, you know, it kind of gets a little bit better and better image as it's going along. So that's about 6 minutes in. The water's kind of dissipated off the lens at that point. Next video. And this one is of the self-cleaning glass. So this is taken on one of the rooftop units. Just did a super soaker and sprayed it right onto the lens. And then they zoomed in on those water droplets so you can kind of see what happens. So I don't want to mislead anybody and say, oh, this is a miracle thing that happens instantaneously. What happens is those dark circles that are forming around those water droplets, as they start to dissipate off, it's going to clean off the glass. And depending upon the weather and the temperature and stuff like that, this video takes about 17, 18 minutes in order for it to completely be cleared off. And this was done in January in Ventura, so let's say 60 degrees. And so depending, it could take a little bit longer, it could take a little bit less. We've got a picture here I'll show you in a little while from Juneau in the middle of the winter that took about 20 minutes for it to kind of come off like that. So, you know, that's the process. That's how it works. It's the same technology that they use in, you know, 100-story skyscrapers on the windows up there. If you notice, nowadays they don't have window washers that go clear up there. So that's the same thing. It's a very expensive process, but it works very, very well. Texas did some ice tests on the camera, and the reason to show you these slides is just to show you how it performs in the very cold weather. And so, as you can see, they took the cameras, they put them in an environmental chamber, and they squirt some water on it, and they freeze up around it. At minus 30 degrees, you can see how that camera tube is completely iced up. Yet in the center, you can still see an image through there. That lower right, there's the picture that correlates with that. And that's due to the fact that the indium tin oxide is put on there in a way that it allows it to defrost from the center out. So the core of the heat is right there in the middle. And as it gets warmer, then it'll warm up around the outside. The next slide shows it a lot better as far as they froze the camera first and then they brought it back to life. And you can see that it starts to defrost from the center and works its way out. One of the things that's notable in there, they were doing these tests in conjunction with two other manufacturers, and the Sidewinder Viper series cameras completely destroyed the other cameras as far as times that it took in order to you know, see visibility, as well as the temperatures and stuff like that. You can still see an image of that. Next slide, please. This is just kind of a situation showing snow on the lens. So the left picture is a competitor's camera in a snowstorm. The right one is our camera. Just the glass stays warm enough in order to you know, turn them into water droplets and doesn't start to form the thing. The snowflakes don't just stay on there. One of the things, just in full disclosure, a lot of this is just like a basic little snowstorm that was happening in this situation. There are very unique storms that will happen. We have some cameras that are on Suquamish Pass that up at the higher elevations, if there is a very, very wet, heavy snow that comes down super, super fast, which it can do in that time period, it will in times pack into that camera tube. And it might take, you know, 12 to 24 hours for that to kind of heat up enough to where it'll drop out and stuff. But Generally speaking, on a normal snowy day, this is what it's going to look like. Next slide, please. And this is the slide that I was telling you about, the hydrophilic glass working in Juneau. And so we just kind of wanted to see in a cold environment to kind of see what would happen with it. So we took a snapshot of basically a snowstorm hitting that, and then how long it took for the window to be cleared off. And you can see there was a 20-minute time lapse within there. So, you know, let's say between 30 and 40 degrees on a snowy day. That's kind of what you can expect to have happen with the glass. Next picture, please. This is just some cameras that we took in Fairbanks just to kind of show really, really cold weather, what the camera does in cold weather. There's the cameras that are in Fairbanks are on a couple of the RWIS sites there, and according to Alaska DOT, they're the only cameras they've had up there that haven't froze at some time during the winter. So kind of a cool thing that the camera performs that well in harsh environments such as Fairbanks. Next slide, please. This is the low light sensitivity of the block. You can kind of see the upper left picture, and this was taken just right before dawn. You can see there's not a lot of light in the sky, but there is some ambient light off the buildings and whatnot. The camera had already switched over to color, and so Lester was taking these pictures, and he actually had to force the camera into black and white in order to see the contrast between the gray scales that the black and white offers, which you can see on the lower right is very, very good contrast between the gray scales. A lot of times, if these cameras are placed in an intersection where you have a lot of ambient light with overhead luminaires and whatnot, you won't even go into black and white during the night. It'll stay in color 24 hours a day. So it doesn't take a lot of light for that, the color mode to stay on. So next slide, please. This is just a spec sheet on our PoE injector. So for the PoE powered cameras, it's a class 8 PoE injector, NEMA TS2 compliant. It's a 90-watt injector, whereas the cameras need, depending on the version of it, up to 62 watts. So it's overbuilt and guarantees that we're not going to have situations where we're going to have, failure due to low power sourcing. And it helps with those longer runs as well. So next slide, please. And then PoE extenders. This is something that over the last several years, there's been a lot of movement and a lot of improvement in PoE extenders. A couple of years ago, we were definitely limited to 328 feet as far as the runs go when we were using Ethernet cable, or we'd have to have really expensive injectors that would have to have their own little box along the way. Two of the ones that we've tested vigorously and really enjoy are the Vigitron injectors that are shown here, and you can go up to 3,000 feet with these extenders. So it makes it very, very easy to not have to worry about having the 328 feet capability. This is just kind of showing how it would be configured. So basically the injector, you could take it right off of the camera in the cabinet and then into the switch, and then it's going to extend your sourcing there. And so super easy to use, and the two different versions, there's the hardened version and there's the non-hardened version, depending upon what use you have for them. This is our camera control, and we'll kind of go into this. We'll play around with it here in a minute when we look at the camera and kind of show you about how that works. The nice thing about it is for all of our products, it uses the same camera control. So if you know how to program a camera, you know how to program any of our devices. And then the Hydra 265. So this is a product that we have had available for almost a year now. And
Hey, Doug,
yes.
can we pause for a second, just ask if there's any questions about the camera?
Yeah.
So yeah, if there are any questions before we move on to the Hydra transcoder, please go ahead and unmute yourself and ask your question.
Hey, Doug, does the Viper camera, does it need to be pressurized?
It does not need to be pressurized. It can be if the spec calls for it, but it is IP68 without pressurization.
So what's the pressurization used for?
So pressurization is kind of a thing that it's not used a lot anymore. But 10, 15 years back when cameras weren't designed in order to be waterproof, they could be pressurized with nitrogen or some other gas, and that would make them waterproof. And so that's what they were used for. Our camera has never needed to be pressurized in order to be IP68 compliant. But if the spec calls for it, it's very easy to, you throw a little Zerk in there and you fill it full of gas and it works. That answer your question, Damien?
Yep, perfect. Thank you.
I had a question for you, Doug.
Yeah.
So picturing this camera hanging upside down from a pole that has one of those lowering mechanisms. I know for dome cameras, that pole a lot of times can get in the way where, if it pans around, you can't see past that post. But the way this is designed, it kind of seems like you might be able to look around it.
Yeah, so one of the advantages to a positioner style camera is you basically have the distance. If you think of the axis of the camera, the straight up and down axis, and then you've got the camera tube is offset. And in this situation, it's about an 8-inch offset. And so if you, with a light pole or, lowering device, any pole that's in the way, you basically have the ability to rotate the camera tube 180 degrees and rotate the camera 180 degrees. And you'll be able to see on the back side of that pole, given the fact that it's maybe no more than 16 inches in diameter. So it really increases the backside visibility of the pole.
Very nice. Any other questions? All right, Doug, go ahead.
Okay. So the Hydra is a very simple product, but it is super, super useful. And so what it is it takes any camera, it's agnostic, so it doesn't have to be a WTI camera. It can be, whatever other manufacturer's camera that is currently being used, and it will turn it into an H.265 stream. So when we first came out with this a year ago, one of the things that was evident out there was in cellular situations or wireless modem situations and things like that, where you're limited on how much bandwidth you have, that people were having a hard time getting a good quality video. So you can utilize this device by plugging it into the switch that the camera is plugged into, pulling that video out, telling the transcoder that you want to compress the video down to an H.265 stream, and then ship it along back to the head end and break it back out. And the processor within the Hydra is powerful enough that you can do up to 16 standard def feeds through it, 8 720p high definition feeds, or 4 1080p high definition feeds through the Hydra at the same time. And you can do multiple ones. It doesn't have to all be of the same one. So if you, as an example, if you are currently using a standard def camera and doing standard def feeds, it'll save you approximately 75% in your bandwidth in order to do that. So at first our thought process was, hey, this is a great way to utilize in those, like I said, the wireless and the cellular situations. However, what we've found over the last year is there's a lot of DSL systems, a lot of fiber systems as well, to where they are becoming overload. And even though you have a fiber system that can be upgraded, it's expensive to do that. And these devices can be deployed onto older cameras that aren't set for replacement for many years down the road. And it gives them a new life and an ability to get great image quality through the into your system. So next slide there, please, Lester. This is a little image of just kind of how it works. So it doesn't matter if it's, like I said, whichever camera it is, it can actually be detection cameras as well. You plug the Hydra into the switch, you designate which feed you want it to compress, and then you ship it back to your head end. If your head end accepts H.265 feeds, which most of the software nowadays does, then you don't even need to have a Hydra on the back end there. If it doesn't, you can deploy another Hydra on your head end, and you can break the video back out into whatever your software would like as well. So that's just kind of a graphic that shows logistically how that would work. And that's all the Hydra is. It's that simple. It's straightforward and easy to use. So any questions on the Hydra? Going once, going twice. Okay. So,
Hey, Doug,
yeah.
real quick, on the Hydra, can you use it in intersections that use video detection?
Yeah. Yep. So you can, any video device, the Hydra will transcode it. So it doesn't matter the manufacturer. It doesn't, you could have access cameras there. You could have, whatever. And your detection cameras could be whoever detection camera you have, and it would be able to use that as well. So if they would like to be able to use their detection cameras and see them back at the head end, but they're not having the bandwidth to do that, this is a great solution, because you can plug, like I said, up to 12 different devices into it. So not a problem doing that. So if there's no other questions, we'll kind of move on to just showing you some of the logistics. This whole package, the slide right here, the main thing that we want to stress is, like I started off with, WTI, we're based in Ventura, California. It's a small family-ran business. 90% of our business is traffic related. That's what we do. That's what we try to be good at. The products we put out are high quality products that are meant to be in use for years and years and years. And we support them. And that goes from, in the field support to software support to whatever you need. We have a lot of customers in the Northwest that, when we first introduced them to the camera, they said, well, we wish it would do this. Well, we've gone through and we've adapted the software to make it fit their situation and at no additional cost. And that's something that we really pride ourselves on, is being customer focused and making sure that we're providing the products that traffic industry wants. Because if one municipality or one DOT wants that feature, we can almost guarantee that there's going to be other people across the country. And it has become like this living process that has kind of helped many, many customers. So with that, let's just kind of go into the camera control and kind of show them some different features and stuff like that. So this is the camera control, and this is a downloadable GUI. And our software group will download updates to the software anywhere from 1 to 2 times a year. And so it's very easy to use. You plug into the switch, you make sure your camera's on or your laptop's on the network that the camera's on to begin with, and you connect to it. And then from within here, you can set all the different features. You can change things up. Left-hand side there, you've got all the shutter things, the middle panels. You've got the encoders. So this is where you can set up the 8 different encoders, the different feeds that you wanted. And within those, you can direct where they go. So if you had, you know, one that you wanted to go to your TMC, and then you had another one that you wanted to go to the police department or whatever not, you could do that. What Lester's showing you here is basically the 3 different encoders that we have turned on right now. So we have an H.265 feed that's turned on, and then we've got another H.265 feed at 1920. The other H.265 was at 1280, so different resolutions. And then the third feed, we have an MJPEG, and so that's at 720. And so 3 different feeds, 3 different resolutions coming out of the camera. And where do you want me to go with this, Lester?
You want me here? I'll show you the pan and tilt, 360 degrees.
Since Lester's running the controls today because of some technical issues, we'll let him kind of tell you what he's doing as he's doing it here.
So you see here, the camera will do 360 degrees continuous rotation on the pan and the tilt axis. And this is where we can look around a blind spot. Oops, too far. So you see there's more field of view here, looking to the left side of the camera on the left there, on the right there, than it was before. Camera 30 times optical zoom. Oops. And the pan and tilt speed is directly proportional to your zoom. There you go.
Hey, Lester, what does directly proportional to your zoom mean?
So I'm going to show you that here right now. So basically, as you can see here, we're in digital zoom, and the camera, you see the crosshairs here. The camera pans and tilts at 100 degrees per second, proportional to your zoom, to where you can see here, it looks like it's moving faster. It's actually moving extremely slow. Let me back it out here a little bit more. So, you see it's going as fast as it can. You see how slow the camera is panning. Let me, if I zoom it all the way out. Then you can, you see how fast it's going. So it's 100 degrees per second. And again, it's proportionate to the zoom position. So the more zoomed in you are, the slower the pan and tilt speed. Some of the other features that we have here are idle timeout settings. This is a great feature to where we actually developed this for Maryland DOT, where they would have challenges with operators moving the cameras and then leaving them there, so they wouldn't be in the proper designated position. So the shift changes. Oh, I guess, hold on a second. Let me plug in my camera, or in my laptop. The shift changes, and the new operators come in, and they realize all of their cameras are out of position, or some cameras are out of position because of the previous operators. So then what they do is, so what they ask us to do is can we develop a feature to where if the camera is out of position, it'll automatically go to a certain preset after a designated amount of time? And that's exactly what this does. So basically, you can tell the camera after to go to a preset 1 or 2 or whatever preset you want, and after 60 minutes or anywhere from 15 minutes up to 4 hours, the camera automatically will go to a certain preset. So that's one of the cool things about this feature here is it automatically go to a designated preset if someone moves the camera. So, and then there's we can set tasks here to where you can set up a task. So let's say every day you want a certain camera to point northbound. So it doesn't matter where it is, you can set up a task to at 4 o'clock in the afternoon, it's going to point northbound. Or let's just say in the afternoon, in a certain approach, you get a lot of glare off the windshield. So you can set up a task at 4 o'clock in the afternoon to turn on the wide dynamic range. And then say at 8 o'clock in the evening, you have it turned off. So there's some, so you can set up some of these tasks, or let's say you have a certain approach, it gets a lot of fog in the morning. So you set up a task at 4 o'clock in the morning to turn on the defogging feature. And then you have another task at say 9 o'clock in the morning to turn it off, or later on. So, you can set up tasks to direct the camera to do whatever you want to do. And then again, the idle timeout settings is available for you to, in the event people move the camera out of position, after a certain designated amount of time, the camera automatically moves to a designated preset. Doug, what do you want to show them next? The Hydra?
Yeah, let's do the Hydra. We can show them the web GUI at the same time as the Hydra.
So this is the Hydra 265, and the great thing about it is that the same camera control software that supports the Viper camera and the Sidewinder cameras also supports the Hydra. It just has a different format to it. As you see, I went to view and went to layout, so it has different layouts. So I clicked on Hydra. So this is the Hydra transcoder. And you can't pan or tilt it because all it does is transcodes video streams to H.265 or 264 or MPEG-4 or MJPEG. So here what we're doing is we're telling the Hydra, I want you to go pull streams from 2 different cameras. 2 are pulling streams from the 265 camera, and 1 is pulling streams from the 264 camera. And down here, this is what we're told it to do. So out of the 265 camera, we're streaming at 1080p at 4 megabits per second, and the second stream was streaming at 720p. And then, so what we've done here is we told the camera, or the Hydra, to pull these streams, 2 from the 265 camera, and then 1 from the 264 camera. And stream 1 from the 265 camera is streaming at H.265 at 1080p at half the bandwidth as what the camera is outputting. The second stream here is doing the same thing at H.265 at 1080p at 2 megabits per second. And then the third stream is streaming at H.265 at 720p at 1.5 megabits per second. So the web GUI for this, let me, this will show an H.265 stream. So let me go to Explorer. And let me close Google. Okay, so this is the web GUI for the Hydra, and you can see here it's showing the stream, H.265 stream coming out. What's nice about it is you can see the statistics that are coming out of the camera. So let me turn these off. So basically here we're actually showing the output of the streams at red, and then the output of the encoders is is blue. So we're doing 2, 4. What do we say we're doing here? 2, 4. We're doing 2, 4, 5.5 megabits, 5.5 kilo megabits per second. And so the camera is actually outputting 2. So we're actually doing 3 HD streams. So this is actually, in a way, it's saving bandwidth because we're doing 3 HD streams at half the bandwidth versus doing one at 2 megabits per second. And so I'll go back here and I'll change things around here. So hang on just a second. We go to the H.264 camera. Okay, let's test for the output settings. All right, so now let's go to the Hydra. And I'm going to disable let's see. Oops. So changing. All right, so let's test for the output settings here. And then we'll go to the web view. So what I did is I went to the H.264 camera and I asked it to output H.264 at 1080p. And then I went to the Hydra and I asked it to take that 1080p stream at 4 megabits per second and to, I might not have done it right, and to output 1080p at 2 megabits per second. So I didn't, yeah, 265. So it should be working. All right, so I apologize. For some reason, I'm not doing something right here. So it's gotta be this stream. Okay, there it goes. All right, so I'm going to apologize. It's not working the way it's supposed to be working. So let me try this again. All right, so I apologize. I and don't have this configured properly here. Let's go to setup, sources. Why isn't it pulling it? That's correct. Let's do this. I know what I did. I'm sorry. Let's just go to the H.265 camera. Let's change this to 264 and then 4 megabits per second. There we go. Okay, so now I'm going to go to the Hydra. All right. All right, now it should work fine. Now it should be working. Okay, so now let me go back here. I told the H.265 camera to I changed the encoder one to H.264 and a 1080p at 4 megabits per second. All right, simulating an H.264 camera. And then I'm telling the Hydra, when you take that 264 stream, transcode it to H.265 at 1080p at half the bandwidth. So you see here, the red line represents the output of the camera again, at 4 megabits per second. And then the blue line represents the output of the Hydra at 2 megabits per second. So you see here, I'm saving 50% bandwidth here. So this is how, again, the Hydra can basically make all of your current cameras H.265 cameras. All we need is an RTSP stream, and we can transcode those cameras from 264 or even MPEG-4 to H.265. And then again, from MPEG-4 to 265, you'll save up to 75% bandwidth. From 264 to 265, you'll save up to 50% bandwidth. So sorry about the little technical difficulties. That was all on me. I didn't have the cameras configured properly, so I just changed it, so now it's working properly. So anyway, this just shows you that this is how the Hydra works, and it shows you that the Hydra is saving you bandwidth. Any questions?
Hey, Lester.
Yeah.
Will the Hydra work with like different camera softwares, like Chameleon, or like other brand type softwares used at TMCs?
Yeah, because what they're asking for, the Chameleon and say Variant or Milestone, they want an RTSP stream. So you would tell them to pull the RTSP stream or streams from the Hydra's IP address.
Yeah, Damien, the software doesn't care. It just cares what the feed is. So it doesn't know that it's a camera or the Hydra or anything else. It's all about the format that the feed comes into the software.
Perfect.
All right. Do we have any other questions about either the Hydra transcoder or the Viper camera?
So Ryan, how many outside people do we have on this call?
What do you mean by outside people?
Like, how many customers of Coral sells?
Oh, it looks like 4.
Okay, so just everyone that's on the call, we're more than happy to do demos of the devices for you. So if you have a situation that you can think of that you would like to have a Hydra demo, or you would like to demo the Viper camera, just let Coral or myself know, and we're happy to coordinate that and make sure that that you guys have an opportunity to, see how it works in your real life situation.
Yeah, absolutely. So yeah, like Doug said, if any of you would like to set up a demo, just contact us and we'll make sure we get it set up with all the bells and whistles that you want, check all your options and get you a demo camera out there in a location of your choosing, and we'll help you set up the software and do some training on it. So if any of you would like to do that, let us know and we'll get it taken care of.
If you'll share with me later, Ryan, email addresses, I will make sure to send out spec sheets and literature on the stuff that we talked about today.
Absolutely. That being said, I want to thank everyone for attending, and I hope everyone has a very wonderful day.